Hello friends, we are seeing unit 3 MOSFET. In previous lecture we had seen different types of MOSFET. In today's lecture we are going to see in detail N channel depletion MOSFET. Here the figure shows the construction of N channel depletion MOSFET. D MOSFET or DE MOSFET. This MOSFET is called as depletion MOSFET, is known as D MOSFET or DE MOSFET. DE MOSFET because it can be operated in both the depletion mode and enhancement mode. It consists of highly doped p-type substrate into which two blocks of heavily doped n-type material are diffused, forming the source and drain. Here we can see this is the p-type substrate, and in this two blocks of heavily doped n-type material are diffused to form source and drain. N channel is formed by diffusion between the source and drain. Here the N channel is formed by diffusion between this source and drain. The type of impurity for the channel is same as for the source and drain. Here SiO2 layer is grown to make contact for source and drain. By the process of metallization, the metal is deposited to provide drain and source terminals, and a metal plate is deposited on the surface area between drain and source, which constitutes the gate. By the metallization process, the metal is deposited here on the SiO2 layer, or the openings make here for depositing the metal, which provides the terminals for drain and source, and a metal plate is deposited on the surface area between the drain and source, which constitutes the gate. The SiO2 layer provides extremely high input impedance of the order of 10⁻10 to 10⁻15 ohm. Due to this SiO2 layer, it gives the it provides the extremely high input impedance for the MOSFET. The chip area of MOSFET is typically 0.003 micrometer square or less, which is nearly 5% as compared to the BJT. A p-channel DE MOSFET is constructed like a n-channel DE MOSFET, starting with n-type substrate and diffusing p-type drain and source blocks and connecting them internally by p-doped channel region. Here we can construct the p-channel MOSFET likewise same as a construction of n-channel MOSFET, only here the p-type substrate is used. In p-channel MOSFET the n-type substrate is used, and here the p-type drain and blocks are made for connecting them internally to the p-doped channel region. Okay, so this is about the construction of N-channel depletion MOSFET. Further, we will see the working principle of depletion MOSFET. Here we can see this figure shows the working principle of N-channel DE MOSFET. The DE MOSFET can be operated with either a positive or a negative gate. DE MOSFET हा आपण त्याला गेटला व्होल्टेज पॉझिटिव्ह किंवा निगेटिव्ह देऊन त्याला ऑपरेट करू शकतो. फॉर VGS is equal to negative, if we apply here the gate to source voltage negative, then this MOSFET will operate in the depletion mode. and for VGS is positive, then it will be operate in its enhancement mode. Now we will see here VDD is connected across drain and source terminal. We can see here the negative terminal is connected to the source and positive terminal is connected to the drain, and let VGS is equal to 0. Then due to the positive voltage at drain, the free electrons flow through the channel from source to drain, constituting a drain current. जर इथं आपण गेट टू सोर्स 0 व्होल्टेज अप्लाय केलं तर ड्यू टू दिस पॉझिटिव्ह ॲट ड्रेन टर्मिनल, the free electrons will flow from source to drain here, from source to drain, and this will constitute a drain current. This drain current with VGS 0 is called source saturation current, that is IDSS, and its maximum possible value of ID that can be flow through the device. This source saturation current is nothing but the, if we apply VGS 0 and at that time the current flow through this channel or from source to drain, that current is known as IDSS, and it is a maximum current, it is the maximum value of ID that flow through the device. Now case 1, that is depleted mode. For depleted mode, VDD is applied and VGS is made negative. Due to the negative voltage at gate, the electrons in the channel are repelled towards the P substrate. Here VGS is made negative, and due to negative charge at gate, the electrons in the channel will get repelled towards the are repelled towards the P substrate, and similarly the holes are attracted towards the negative potential of gate. The repelled electrons will recombine with the holes which enter the channel, so availability of electrons for conduction get reduced. Hence the drain current ID will decrease. Further increase in this VGS, that is negative VGS, the free electrons reduces and therefore ID decreases accordingly. With negative VGS, this MOSFET operates in the depletion mode. Why depletion? Because as the channel is depleted of free electrons, so it is called as depletion mode. Thus with more negative voltage, we will get the MOSFET will operate in the depletion mode, and the MOSFET will operate in the depletion mode, and in this mode the MOSFET acts as a open switch. As ID is nearly equals at a particular value of VGS, the ID becomes 0. Second one is the enhancement mode. VDD is applied and VGS is made positive. VDD applied आहे आणि VGS या ठिकाणी आपण पॉझिटिव्ह केलं. Due to the positive voltage at the gate, the minority electrons present in the p-type substrate are attracted towards the channel, and hence more electrons will be available for the conduction. या ठिकाणी आपण पॉझिटिव्ह व्होल्टेज अप्लाय केल्यामुळं जे मायनॉरिटी इलेक्ट्रॉन्स असणार आहेत पी टाइप सबस्ट्रेट मध्ये, ते या टुवर्ड्स द चॅनल ते अट्रॅक्ट होणार आहेत, and hence more electrons are available for the conduction. Thus the electrons get enhanced due to the positive gate voltage, so it is called as enhancement mode. Similarly, the construction and working for p channel DE MOSFET can be explained. It is exactly opposite to the n channel DE MOSFET. Now we have to see the drain characteristics of DE MOSFET. This graph shows the characteristics are it is a plot of ID versus VDS at different values गेट टू सोर्स व्होल्टेज VGS. हा जो ग्राफ आहे ड्रेन कॅरेक्टरिस्टिक्स त्याला म्हटलं जातं अँड इट इज प्लॉटेड अगेन्स्ट ड्रेन करंट ID वर्सेस and these are plotted at for the different values of VGS. So it has three distinct regions. First is the cutoff region. In cutoff region, when VDD is applied and VGS made negative for a particular value of VGS, there are approximately 0 electrons in the channel available for the conduction, and hence ID is equal to 0. Here the MOSFET does not conduct and MOSFET work as a open switch. If we see here, this is VGS is equal to 0. Above VGS is equal to 0, it will operate in the enhancement mode, and below 0 it will operate in the depletion mode. So if we apply minus 0.5 volt, minus 1.0 volt, likewise more negative voltage, if we apply more negative voltage, then ID at a particular value of VGS, the ID becomes 0, and as ID is 0 means drain current is 0, the MOSFET does not conduct, and hence this MOSFET acts as a open switch for in the cutoff region. Second one is the saturation region. In this region, ID remains constant, here we can see, and does not changes with changes in the VDS, and MOSFET works as an amplifier. And in the ohmic region, in this region the current IDS increases with increase in the value of VDS, and thus the MOSFET operates as a voltage variable resistor in ohmic region, and in this region the ID is maximum, we can see here. So it acts as a closed switch, that is in the enhancement mode. So these are about the this is about the drain characteristics of DE MOSFET. So in this lecture we studied the construction of DE MOSFET, then working of DE MOSFET and its drain characteristics. In next lecture we will study the construction and working of enhancement MOSFET.